This sum we were doing last time, no? Somebody please respond with this sum we were doing last time.
Yes, sir.
Okay. And have you people found out the elementary matter equation for this? Hello. Have you people found out the
Sir,
elementary matter?
this wasn't the question.
Acha,
It
it's
was similar to this.
acha, it's this we had done. No, this we had done together. Correct. This we had done together. No, this was the sum. No, this we had done together. No, this for this we had found out the global matter equation also. Correct.
So only till global metric
Acha.
equation was done.
Yeah. And then I told that if you people can go ahead with the applying boundary conditions. You didn't find out it by applying boundary conditions. Okay, we'll solve it from here. This global matter equation we had found it already.
Yes, sir.
Okay. So now what we'll be doing is once you have found out the global matter equation, now we'll see the boundary conditions. So what are the boundary conditions that you are getting by looking at this? What are the boundary conditions? There are six variables for deflection. There are six variables for the forces. So there are 12 variables. Out of this, six we should cover in boundary conditions so that we will be able to balance and find out the six unknown variables.
So V2 is equal to 0
Okay.
and uh, P3x and P3y is given.
Okay. Then
U1 V1 0.
okay. Then U1 0. Then there is P3 P3x P3y given. Four conditions we have got.
P2X is 0.
Okay. Five conditions. Okay, we'll see the boundary conditions. Wait a second. So boundary conditions are U1 and V1 are 0. First of all, because both the directions, because there is a fixed support, not a roller support. So in both direction, the deflection will be constrained. So U1 V1 is 0. Here being a roller support, so only one side is constrained. There is a deflection can happen in U direction. So only V2 is 0. Are you getting it? One is fixed support, therefore U1 V1 is 0. And next way only V2 is equal to 0 because roller support is there, and because of the roller support there can be movement in x direction, and if there is movement in x direction there will be deflection in x direction. Correct? Hello. So u1 is equal to 0, v1 is equal to 0, v2 is equal to 0, p3x is equal to 0, and p3y is equal to 0. And p2x is equal to 0 because there is a deflection. See, when there is a constraint, there is a reaction, and when there is a deflection, there is no force given. Because if ruler will be moving over here and there, P2 actually bound to be 0. Are you getting this? I'll come back to this figure again. See, in basic engineering mechanics, we have learned that whenever we have uh, where do we get reactions? First of all, where we get reactions? Where we get reactions? Where we get reactions? Can somebody tell me when we get reactions and where we get reactions? Hello.
Sir, at roller, vertical,
No, no. Generally, where we get reactions? In general,
at
whatever the
support.
at support. So basically, those things which are constrained or those directions which are constrained, there you are bound to get reactions. Now here there is a fixed support, so it is constrained in both x and y direction. So you will be having reactions in both x and y direction. Now a roller support is only constrained in uh, only constrained in y direction because x direction it can move. Therefore, it will not be having any force in x direction. Are you getting it? This is clear. This point is clear. This point is clear. This point is
Sir,
clear.
could you repeat the roller part again?
See, roller part, because it is constrained over here, both the direction may you will have reactions of P1x and P1y over here. Roller part may it is moving along x direction. So because it is fixed over here, it is not having deflection but it is having reaction. Correct? Hello.
Yes, sir.
And here in second at second node, it is having a roller support. So it is constrained only in y direction. X direction it can move. It can move in it can move in front and back in x direction. And because it can move in front and back in x direction, it will have a deflection in x direction. And because wherever deflection is there, therefore reaction is not there. So because it can move in x and y direction over here, it will have only reaction in y direction. P2x will be equal to 0.
Yes, sir, got it.
This is clear for everybody?
Deflection will occur along the x-axis.
Yes, yes. Because roller is there, na? So it is constrained only in y direction. So wherever constraint is there, there will get reactions. Wherever deflection is there, there you will not get any force. Are you getting it? Okay, consider it like this. Suppose you are moving. Suppose you are moving a box, okay, and it is not having any wheels, and the box is quite heavy. Let us say it is 100 kg. So, uh, first of all, why the box is not moving? Why the box is not moving? When you are pushing it, why the box is not moving?
Immense frictional force acting in opposite
So
direction.
basically, the weight here is playing an important role, and because it is not having any wheels, just the box is kept. So there is a complete contact with the ground, and it is basically giving you equal and opposite force of whatever force you are applying. So you are getting equal and opposite reaction. Why? Because it is sort of fixed for me. It is not moving. Because whatever force I'm applying, I am getting equal and opposite force from the box back. To move the box, what I should do? To move the box, what I should do?
A force greater than the reaction force should be applied.
Correct. But it is not physically possible if I have to only push it at my level. So what I can do is I can put some wheels to the box. Now if I apply the same force, the box will be able to move. Hello. The box will be able to move. Hello.
Yes, sir.
Why box will be able to move? Because it is not giving any reaction now. Whatever force you are pushing, it is going in forward direction. Now, if you try to lift the box of 100 kg, if you have put the rollers, will you be able to do it? Will you be able to do it? Hello. My question is clear. You have put roller to the box. Now you are pushing the box. It is going in forward direction. Now you are trying to lift it by your bare hands. The same box of 100 kg after putting the roller. Will you be able to lift it?
No, sir.
Why?
The weight is in the vertical
Because
direction.
the roller is taking off the weight or the force from x direction, not from y direction. So it is not constrained in x direction, but now it is constrained y direction. So x direction, with the force that you are applying, you are able to move the box forward. But when you are trying to lift it, you are not able to lift it because still the force in y direction still exists. So this is the reason why at the second node we will be having a deflection of u2, but we will be having p2x0, but we will be having p2y force because it is constrained in y direction and roller support only allows the deflection in x direction. Is it clear? Is it clear?
Yes.
Okay. So now u1, so boundary conditions for me will be u1 v1 equal to 0 because both the directions are constrained. V2 is equal to 0 because roller support may there will be deflection in x direction, but the vertical uh, direction may deflection is constrained, and p3x and p3y are given and p2x is equal to 0 because u2 deflection is there, and obviously u3 and v3 will be there because forces are there and that particular node is not constrained. Is it clear? Are the boundary conditions clear? So if I put the boundary conditions, my matrix will be somewhat like this, and with this I will formulate the equations and I'll try to find out the values for u2, u3, v3, p1x, p1y, and p2y. Is it clear? Is it clear? Hello. Give me a quick
Yes, sir.
confirmation. Okay. So whenever there is a fixed support, there is bound to have reactions in both the directions because both the sides, vertical and horizontal, are constrained. When roller support is there, horizontal deflection is possible. Only vertical side is constrained. So which particular side or which particular direction is constrained, there you are bound to get the reaction. Now with this boundary conditions, try to find out the other values. I'll give you 5 minutes. Try to find out this values and then we'll discuss it. Quickly try to find out U2, U3, V3, P1X, P1Y, and P2Y. Tell me when you are done, finding the values. Done. Calculation is done for U2, U3, V3.
Yes, sir.
Then you should tell me when it is done. P1x, so see whether you are getting the same values for U2, U3, V3, P1x, P1y, and P2y. Same value you are getting?
No, sir. I might have made some mistake.
Okay. Others also please check.
So there's some difference in the decimal. Like I've done it in 10 raised to minus 3. So U2 is 3.0314 into 10 raised to minus 3.
So how,
U3,
okay, with that value, what are the values of P1,
so
P1x?
P1x is 2 kilonewton matching, P1y is 4.4 and
Okay, it's
P2y
fine.
is 0.59.
Correct. That's okay. That's okay. That is hardly any difference will be making. It's fine. You can
So
continue.
it's tallying anyway.
Yeah, it's fine. If it could have made a significant difference in these values, second decimal approximation is okay, but first decimal instead of 0.5, if directly it could have become 0.6 or something like that, then I would have told you to check. But it's okay. It's fine. It's matching. Others also have completed. Shall we go to next term, or you want more time? And quickly give me replies. Otherwise, I am also stuck that whether you are knowing whether you want more time. Do you want more time, or shall we go to next sum? This is okay.
So 1 minute.
Okay. We'll wait for 2-3 minutes. Let some people calculate, check this equations, and tell me when you are done.
So in this sum, we weren't supposed to find the stresses.
Uh, Stresses they are not, I think, asked. Yeah, they have found out the stresses. So those who are done with that, try to find out stress. Those who are done with this, go ahead and find out stress. Others who have not completed, find out these values. But whenever I'll be giving this sum for test or exam, I'll be specifically telling, you have to find out stress or not. If I have not mentioned stress, just find out the deflection and the forces for truss sums, because truss sums are having generally 6 by 6 matrix, so they are a little bit, the volume of the sum is more. So until unless I tell in question that you have to find out stress, do not find out stress in test.
Okay, sir.
Done. Done. These values you have found out. Hello.
Yes, sir. Finding the stresses, sir.
Okay. I know this sum is taking time, but do not miss any step. Try to find out as much as time it takes. Done. The stress values are matching. The stress values you have found out. Hello. The stress values you have found out. Stress value you have found out.
Yes, sir.
Are they matching?
Yes, sir.
Okay.
Sir, could you show the value for
Yeah,
element
yeah,
3?
yeah. I'm doing that one. And only few people are responding. I want others to respond also. Shall we go ahead with the next sum? Are you done calculating the stresses? Hello?
Yes, sir.
Okay. Now this is a similar kind of sum. I quickly want to draw you. I quickly want you people to draw the node diagram. This is similar to what we have done, exactly same. Only the values are different over here. So quickly start draw the node diagram for this. We'll discuss the node diagram and then start writing the element matter equation. The boundary conditions will be for this sum also will be exactly same as last sum, because here also at second node there is a ruler support. So you will have a deflection in x direction, but you will not have a force in x direction because there is a deflection. So this is how my node diagram will be looking. I'll be having node 1, 2, and 3, element 1, 2, and 3, and I'll be numbering 1, 2, 3, 4, 5, 6 for the forces. So with this information, I can easily find out the table. So if this is over, try to make the table also. The heads of the table I have shown. Once your table is over, once you are done writing the table, tell me, we'll discuss the table then. मन कर रहा है कि नहीं कर रहा है तेरा? तो आप यू आर नॉट आंसरिंग एनीथिंग. हाँ मन. See, from next class, I'll be randomly asking people, and if I find that I'm not getting an answer within a minute from response, answering response from them, I'll be noting their names and I'll be straight away marking an option. Just logging in the class is not enough for you to understand this subject. If you're not getting involved, it's not of any use. Have you understood how to approach the trust problem? Anybody is still having any doubt? I'll explain it again. But if you're not understood, don't just sit idle. All of you understood how to approach this problem, how to solve these problems. Hello. Hello. My voice is audible to you people? Hello.
Yes,
Yes,
sir.
sir.
So please respond whether it is clear. Do you want any explanation? If at all those who are having doubt, please ask, or if whether it is clear. And one more thing I want to tell you from one thing that though this is an online class, but I want your involvement. If you are having any doubt, you can either wait for my explanation to get over, or you can stop me in between and ask that how sir this value has come or how to approach this thing. Because if you just sit there ideal, it will be your loss. And second thing, this from this year onwards, we are whatever when we are downloading attendance at what time you were there and what time you had logged out, what time you are logged in, all is captured, and we are uploading our attendance directly from SAP. Whatever Excel sheet we are downloading over here, we are directly uploading it. And if a student is joining a class after 15 minutes from the lecture starting, his attendance is not considered by the system. So as we had some scope for adjustments of attendance earlier when we were taking physical attendance in class. Now, because it is all system based, we are not having any options. So be very careful with your attendance. If at all there is any internet issues that at your end, some genuine issues are there, and you were in lecture and you logged out, and if at all if you log out, try to log in within as soon as you can. And if there is some problem that very same day after lecture, please convey me so that before uploading the attendance I can consider that. Otherwise, if you are not conveying us, then whatever attendance that we are getting, we don't know what genuine problems you are having. Maybe some problem, some a particular day you are facing. So if you are having any problem with connections, or if you are having any other problem and you are not able to attend the lectures, or some connectivity issue is there, then that very same day you should inform me. Otherwise, whatever attendance that I have downloaded for that particular lecture on that day, I'll be uploading the very same day. Okay, so be very careful with your attendance, because now it is all system driven. So when you are logging in, how much time you are there, how much time you are logged out, it's all seen over here. Is it clear? Is it clear? And I'm not asking you some. I'm just telling you
Yes,
how
sir.
Yes, sir.
are only these two girls are responding. Others are what your mics are not working or what? Okay, so I'll just quickly explain this table again for those who are not understood, and those who are understood, you know, it will be a revision for you. So as soon as we are drawing a node diagram, we are writing down the node 1, 2, and 3 in uh, in the figure that we are there, and we are writing the element 1, 2, and 3. After that, the table is heading is having element the nodes ing, that is the first node and the second node. Then we have xi, yi, xj, yj, the length l. Then we calculate small l by xj minus xi upon l. M is equal to yj minus yi upon l, and then whatever value we are getting for l and m, we are calculating l square, m square, and lm. Now for the we are having first element we are having node I as node 1 and node j as node 2. Since we have considered node 1, so xi yi for we have considered as origin, so xi yi will be 0. Xj yj, the 2.5 plus 2.5 meter, the length of the element is there. So there is no displacement in y direction, there is then only displacement in x direction, therefore we have phi 0. Therefore, if we even if you use formula or it is completely horizontal, so there is no need in this case. So length is directly phi, and this all we are considering in meter only. I am not converting it in meter because when we are dividing it, let it be mm or meter, L and M will not have any units. So xj minus xi is also phi and length is also phi. So I am getting L as 1. Because yj and y are 0, I am getting m as 0. So L square, m square, Lm I have found out for the first element. Now if I go to second element में my second node become my ith node and the third node becomes my jth node. So my xi and yi will be phi 0. Now they have directly given 2 meter height in y direction. So my xj is 1.5 because straight away they have given in diagram. So my xj is 2.5 from the origin in x direction, and node 3 is 2 meter in vertical direction from the origin. Therefore, my xj yj is 2.5 comma 2. Now, if I use the formula that we have seen previously, that is root over xj minus xi the whole square plus yj minus yi the whole square ka root, then the length that I am getting is 3.2. Now, this xj minus xi, that is 2.5 minus 2.5 minus 5 is negative value, and that when divided by 3, 3.2, that is minus 2.5 divided by 3, I'm getting minus 0.781. Yj minus yi, that is 2 minus 0, that is 2 divided by 3.2, I'm getting 0.6247. I'm squaring both this value, that is 0.781 and 0.6247, I'm getting 0.61 and 0.39. When I'm multiplying L with M, I'm getting minus 0.488. Okay, so this is the second element we have calculated for this for second element we have calculated L square, M square, and Lm. Now for the third node, my my third node becomes the first element, and first node becomes the jth element over here. So xi becomes 2.5 into, that is nothing but the third node coordinate, and the first node we already know its origin, therefore it is 0 comma 0. Again, if we use the formula root over xj minus xi the whole square plus yj minus yi the whole square, I am getting the length as 3.2. And because xj and xi is the difference is coming same, so L is minus 0.782. And for yj minus yi, previously in earlier element it was coming as 2, here it is coming as minus 2, but the L is same, so it is coming as minus 0.6247. And after this, I am calculating L square, M square, and Lm for this. Now here L square and M square are same because negative value you are squaring or positive value you are squaring, you are getting the same value for square. But Lm I am getting positive because negative to negative I will be getting positive. So till this point everything is clear. Till this point everything is clear.
Yes, sir.
Okay. Now once because we are calculating L square, M square, and Lm because in our uh, in the element matrix equation, we have to find we are have to find out L square M square Lm for all the values, because the element matrix equation for truss is in terms of L square, M square, and Lm. So we are finding out this value for every element, and then we are substituting it over here. Now, once the table is done for all the three elements, we are calculating the A by L value for all the elements, and then we are going ahead by finding the element matrix equation. So if this is done, I want you to go ahead and calculate the element matrix equation. If this is, you have still doubt in this, you can ask me. Or if you had made some mistakes in calculating the values, these values, I want you to look at the table and correct those values. And those who have completed the table, or those who have correctly made the table, go ahead and find out the element matrix equation. Okay, this question will be continuing in next lecture. Whatever, if you have any doubts, we'll discuss the next lecture. Those who have completed table, try to at least find out the element matrix equation, so that in next lecture we can quickly go through the element matrix equations, and we can directly start with finding out the global matrix equation and applying the boundary conditions. I hope you are understanding this. If you are having any doubts, please let me know. Okay. And next class, I will be randomly asking people by names, to, so that it is, I'll be also in position to, know who are the people who are, actually attending the class, and who are the people who are just logging and going out. Because, this is for your betterment. Though the lectures are online, but we are putting the same efforts, or we are putting the more effort that we were doing for classroom teaching. And the mode of delivery has changed, so you also should be little serious. There are only few people who are seriously attending the lectures, others are just doing the formality. So next time, so I'll be randomly asking any step in between to any person, and if she is, you know getting wrong or not, and that's okay. But if she is not responding only, then I'll not be considering the his or her attendance for that lecture. Is it clear? Is it clear?
Yes, sir.
Okay.
Sir, what will be the syllabus for FA for term test 2?
Yeah. For syllabus for FEA for term test 2, it will be thermal analysis, heat transfer, and truss. And for all other subjects also, you will be getting the consolidated syllabus uploaded, I think today or latest by tomorrow on the Teams. So like you had, syllabus, and the type of paper last time. So by tomorrow you will be getting for all subjects. So as FEA is concerned, you will be having truss, you will be having thermal analysis and heat transfer. Okay.
And sir, for theory part, you will be providing us with the question bank.
Yes, I'll be, but I have not, I am thinking of giving you complete numericals this time. Let us see. I'll be till tomorrow. I'll make my decision, and if at all I am giving one or two theory questions, I'll be definitely giving a question bank. But if at all for this test, if at all there will be a theory question, there will be only a single theory question. All other sums will be sums only.
Okay, sir. Thank you.